Okay, here's a short video for the missing questions on practice test unit 8. Here we go. Let's solve this inequality. There are 3 steps to solving an inequality. One is just solve the inequality, and you could even pretend it's an equal sign, all right? Step 2 is to plot, step 2 is to set your denominators equal to 0 and solve and get more answers. And then the last step is to plot your answers and test the areas so you could know if you have 2 separate inequalities or a compound inequality or maybe just one inequality. So let's begin by solving this thing. I want to multiply everything by 10. Okay, so times 10 times 10 times 10. That will give us 40 divided by 5, which is 8, and it'll be over x. Or instead of multiplying and then dividing, you could have actually just seen the 10 and the 5 and actually divided right there. 10 divided by 5 is 2. And of course, 2 times 4 is 8 over x. So I really have 8 over x. Then over here, the 10 and the 10 cancel out. I end up with a nice, beautiful plus 1. Then I'm going to pretend it's an equal sign. All right, I'm not even going to put it as an inequality. And then I have 10 divided by 2, that's 5, and then 5 times 3 is 15 up on top over x. Or I could have said 10 times 3, that's 30. 30 divided by 2 is still 15 over x. Either way, you end up with 15 over x. Now, to get rid of the other fractions, I'm going to multiply everything by x. This times x, that times x, that times x. Of course, these guys cancel, these guys cancel. What do I have left? I have an 8 plus 1x equals 15. Subtract 8 on both sides, and you will end up with your final answer, x equals 7. Now, that's if it were an equation, you'd be done. But it's an inequality. And we know that in addition to solving them, you need to set your denominators equal to 0 and solve. So that 5x equals 0, which is really a 5 times x equals 0. When you divide by 5, divide by 5. 0 divided by any number is still 0. So x equals 0. It's technically another answer. And you get the same answer over here. When you set 2x equal to 0, of course, x is going to equal 0 as well. So what you need to do is plot those answers on a number line. Whoops. So here's my ugly number line. I have 0 and I also have 7. And now I need to test where the answers are at. So if I test a point like, let's say, -1, that's this area over here. If it works, then I know the inequality is going to be x is less than 0. If it doesn't work, then it's probably x is greater than 0. But let's work on this first area. Let's see if it works. So let's plug in a -1 into the original inequality. So I really have 4 over 5 times -1. That's really -4/5, right? When you multiply by negative, that's a -5, and that'd be a fraction 4 over -5, which is really -4/5. So let me write that down, -4/5. Okay, then I have plus the 1/10. I'm just going to write it, 1/10, and then is less than 3 over 2 times -1. So that'd really be a -3/2, okay, which is really a -1.5. So you could do this math with a calculator and verify that it is less than that. And if it is, then it is a true statement. So all your answers are over here. But let me actually work it out by hand. I need a common denominator. So I'm going to multiply the 5 times 2, that times 2. I'm going to get a -8 over 10, which is the same thing as -4/5, plus 1/10, okay, is less than -3/2, or you could even say 1.5. Okay. Anyway, let's combine -8 plus 1. That's going to be a -7/10. -7/10 is less than -1.5. Also, -7/10 is really like a -0.7, right? And this is really a -1.5. So is -7/10 less than -1.5? Is it further left than -1.5? Absolutely not. This is false. -7/10 is closer to the number 0 than -1.5, which means that it's greater than -1.5. So this is a false statement. This is false. So that means that this does not work. No. Okay. The area over here does not work. Let's test the area in between the 0 and the 7. Like, let's test the value 1. Okay, so that's going to be pretty easy because 4 over 5 times 1, that's just 4/5. So let me write that down right here, 4/5. And then 1/10, that's a plus 1/10, and then plug in the 1 right there. 3 over 2 times 1, that's really just 3 over 2. So we have is less than 3 over 2. Okay, so let's actually add the fractions here. 10 times 2 times 2, you get 8 tenths plus 1 tenth. That is 9 tenths, right? And 9 tenths is at less than 3 halves. 9 tenths is 0.9. 3 halves is 1.5. So 0.9 is definitely less than 1.5. So this right here is a yes. Okay? These middle values will work. And the values over here will not work. Okay, like let me just pick any number over here. Let's say, I don't know, the value 10. Okay, the value 10. If I plug in 10 right there, I'll get 4/50ths. Just jot that down somewhere. 4/50ths plus 1/10 is less than 3 over 2 times 10 is 20. Okay. So when you go common denominator 50 times 5 times 5, you get 4/50ths plus 5/50ths. Is it less than 3/20ths? Okay, and that'd be 9/50ths. Is it less than 9/50ths? Is it less than 3 over 20? And you could actually get a calculator and change them to decimals, so you could see it as a decimal, compare them as decimals. 9 divided by 50 on a calculator is 0.18. Is that less than 3 divided by 20 on a calculator, which is 0.15? And the answer is no. 0.18 is greater than 0.15. So this did not work. So this did not work. As you can see, the only area that works is from here to here, which is the compound inequality answer. Here's your final answer. 0 is less than x is less than 7. That's a compound inequality. I believe you will have to type this in on the quizzes. And just to let you know, if the areas would have been apart, then you would have said x is less than 0 or x is greater than 7, right? If they would have been apart. But because they're together, you're going to write them together as a compound inequality. Okay. And it is possible that you get more than 2 answers, right? You might have a compound inequality, and in addition to that, like -2 and going to the left. We'll get to some of those later. Anyways, I hope this one makes sense to you. All right, this is a fun one. Fun one. Fun with the capital F. All right, so again, we need to solve this thing. We could pretend it's an equation, pretend it's an equal sign if you want. Solve it. How do you solve this? You want to get rid of fractions. I'm going to get rid of the first fraction by multiplying everything by 3. Okay, so obviously that cancels. What do I have left? A beautiful x, a minus sign. This obviously is not going to cancel with that denominator, so I'm going to multiply 1 times 3. That'll be a 3 over the x minus 2. So we have 3 over x minus 2 is less than, just simply comes down. And now notice up here we have a binomial times 3, so I actually have to distribute. Don't forget to distribute. So my answer will be a 3x plus 3 over 4, okay? So I got rid of one fraction. Let's get rid of the other ones. I'm now going to multiply everything by this denominator, x minus 2. X minus 2 right there, x minus 2 right there, and an x minus 2 right there, which could get a little complicated because you do have a binomial times a binomial, which means you have to do a lot of distributive property, or you have to do distributive property and combining like terms. Check it out. 3x times x, that's 3x squared. 3x times -2 is -6x. And then positive 3 times x, that's positive 3x. Positive 3 times -2 is -6. You could combine the middle terms, giving you 3x squared minus 3x minus 6. And of course, that is still over 4. So that is still over 4, okay? The inequality comes down. As a matter of fact, we said we could pretend it's an equal sign. I'm going to leave it as an equal sign. What happens over here, this works out beautifully. That cancels out. I end up with a minus 3. So that's what I have left over, a minus 3. And over here, I need to distribute as well. I want to distribute x times x. That's x squared. X times -2, that's a -2x. So what I have now is x squared minus 2x minus 3. I can't combine any of those terms. And I have this fraction that has a quadratic trinomial over 4. So I need to get rid of this fraction, obviously, multiplying everything by 4. Times 4, that'll cancel out beautifully. Times 4, that'll become a 12. Times 4, times 4. So what do we have left? We have a 4x squared minus 8x, right? If I multiply 4 times negative 2, it's a minus 8x. Minus 12 equals 3x squared minus 3x minus 6. That is a huge, disgusting polynomial, but at least I don't have any fractions. So I need to move everything to one side, set it equal to 0. Let's subtract 3x squared, cancels, subtract 3x squared. That actually helps us a lot. We end up with a regular x squared, or 1x squared. I'm just going to leave it as x squared. What else? We could also add 3x, cancels, add 3x. What does that give us? It gives us a negative 5x. And last but not least, I could add 6, of course cancels there, and over here, negative 12 plus 6, that is negative 6. And now it is set equal to 0. And now I need to recall that quadratic trinomials that have the a value of 1, a lot of times you could factor them thinking what times what is your c value that if you combine together is your b value. If you need help, make a list. Negative 1 times 6 or negative 2 times 3. Those are the only two possible ways of getting negative 6 as an answer. So when you add these, what do you get? You get 3 plus negative 2, that's 1. Is that b value of 1? Heck no. Right here, 6, take away 1, that is 5, but I want it to be a negative 5. So I have the right numbers, but I have the wrong signs. So please change that to a positive 1 and a negative 6. Positive 1, negative 6. That is still equal to 0. Now we could use zero product property that says when you have something times something equals 0, the first something could be 0, and also the second something could be 0. So you simply split them and set them each equal to 0 and then solve, giving you your final answers, x equals negative 1 and x equals positive 6. Okay, that was a lot of work. However, we're still not done because we still need to go to a number line and plot our answers. And not only that, we still need to go to our denominators and set those equal to 0, okay? So that's why I zoomed back out so I could see that this denominator, x minus 2, that could be set equal to 0. You can't set 3 equal to 0. You can't set 4 equal to 0. But you could set x minus 2 set equal to 0. And when you solve that, you're going to get another answer, right? Plus 2, x equals 2. So you have three answers. X equals 2. You have x equals negative 1 and x equals 6. So let's plot all three answers on a number line. So those are our three answers. Let's plot them on a number line. Obviously, the number 6 is over here on the positive side. The number 2 is a little bit less than 6, and the number negative 1 is over here on the negative side. Let's test some values. So, of course, I want to be able to look at the original equation as well. I'm sorry, let's zoom back over there, or see the equation once again, the original inequality, my bad. And let's test a point, like let's say negative 2, right? So if I did put a negative 2 right here, let me actually write that down so you could see me test negative 2. So when I test negative 2, it's going to be a negative 2/3. Let me write that down somewhere. Negative 2/3. And then minus 1 over negative 2 minus 2. It's going to be 1 over negative 4. So that's really a negative 1/4. But with the negative in the front, that's really a positive 1/4. So plus 1/4. And then the less than symbol. And then over here, plug in a negative 2 right there. Negative 2 plus 1 is negative 1 over 4, so a negative 1/4. Negative 1/4. So we're going to test to see if this is true. You could do this with a calculator, which I just did on my calculator, and it gave me negative 5/12. And negative 5/12 as a decimal, the calculator could do it for you. That's negative 0.41. Okay. And the question is that less than negative 1/4, which is negative 0.25? And the answer is yes. So this did work, okay? This answer, -2, did work. That means that all my answers over here work, which means I need to represent that inequality as part of my answer. Okay, so a part of my answer will be x is less than -1. That's for sure a part of my answer. But we still need to test the other values, okay? So let's test this value right here. Let's plug in a value like 0, which should be a little easier because when I plug in a 0 right here, actually let me show you that I'm plugging in 0. I'm gonna put a 0 right there. So 0 divided by 3 is still 0. -1 over -2. Negative and negative is a positive, so that's really a 1/2. So 0 and a 1/2, that's 1/2. Is it less than 1/4? Right, because 0 plus 1 is 1 and 1 over 4 is 1/4. Is 1/2 less than 1/4? That is false. 1/2 of a tank of gas is greater than 1/4 of a tank of gas, right? So that is false. As you can see, it did not work. But we now need to test the value over here, right? Like let's say between 2 and 6, I'm gonna say 4. Sure, why not? Let's do 4, okay? Or 3, let's do 3. 3 will work out nicely. Let's try 3. So if I plug in a 3 right there, 3 over 3 is 1. Let me actually jot that down over here, 1 on the side. And then 1 over 3 take away 2, that's 1. 1 over 1 is 1. So 1 take away 1, 1 take away 1, is it less than, plugging in a 3 right here, 3 plus 1 is 4, 4 over 4 is 1. Is it less than 1? So 1 take away 1 is 0, and that is less than 1, so it does work, okay? So right here, the answer 3, it's a yes, it worked, which means that the answers will, well, it might be that x is greater than 2, or if it doesn't work out here, it might be between 2 and 6. So we still need to test this value out here. Let's plug in a number like, I don't know, 10. Sure, why not? Let's plug in 10, see how that works. Positive 10, way over here. If it does work, then I'm going to say that from 2 this way it works, so it'd be x is greater than 2. But if it doesn't work over here, then that means that it stops right here, so it's a compound inequality between 2 and 6. So plugging in 10, I'm going to get 10 over 3. Okay, so 10 over 3. 1 over 10 minus 2, that's 8. So you have minus 1/8. Is it less than 10 plus 1 over 4? That's 11 over 4. 11 over 4. Again, I'm going to use a calculator on this one. 10 over 3 on a calculator minus 1 over 8 on a calculator. That is 77 over 24. As a decimal on a calculator, that's 3.208, and it keeps going. Is that less than 11/4? 11 divided by 4 on a calculator is 2.75. 2.75. So as you can see, this is false. So this is a no over here. So that must mean, since it worked over here, it did not work right here. It did work right here between the 2 and the 6, and it did not work over here on the right side of 6. That must mean that we have a compound inequality from 2 to 6, like this. So this is as complicated as it gets, guys, where you have a single inequality, x is less than -1, but you also have a compound inequality between 2 and 6. So your answer, your final answer is going to be x is less than -1, or it's going to be between 2 and 6 with the x in between with the less than symbols. So technically, this is your entire answer. So on the multiple choice, you can't just select x is less than -1. You can't just select 2 is less than x is less than 6. It has to be both of them. It has to be a multiple choice answer with both of those answers together, which is a single inequality and a compound inequality, but you have to do both of those. I don't know if you could see this. Let me actually bring it forward. But here's the answer. And as you can see, it's the one that has both the single inequality and the compound inequality. That doesn't always happen, but it did happen on this particular question. All right, here's a regular simplification problem, okay? And it does require some tricks. What do I mean by some tricks? Obviously, you need a factor first. Now, you're thinking, oh, this is a quadratic trinomial. It could be factored. Yes, but there's a negative sign in front. We're used to having an x squared, right? We want a positive x squared, not a negative x squared. So one trick to change signs is to simply factor out a -1. And when you factor out a -1 from the denominator, you're going to now have a positive x squared, a -4x, and a -32. And now you could think of factoring that quadratic trinomial that no longer has a negative in the front. It's out here in the front of it. Now it's a regular x squared, so now you can put x, and now you got to think what times what is your c value, -32, that if you combine together is your b value, -4, and you might want to make a list. So that'd be a -1 times 32, -2 times 16, -3 doesn't work, -4 times 8, -5 doesn't work, -6 doesn't work, -7, that's about it, right? So which of those pairs of numbers combines together to give you the -4? And just start adding them, right? 32 take away 1 is 31. That's not a 31. 16 take away 2 is 14. That's not a 14. 8 take away 4 is 4. That is a 4, but it's a -4. So I have the right number, just the wrong sign, which means I have the right numbers, just the wrong signs. So I have a +4 and a -8. +4, -8. Okay, so all I've done was factored this original quadratic trinomial that had the negative sign in front. I factored it to look like this: -1, still -1 on the outside, times this binomial times that binomial. So all I did was rewrite this whole thing to look like this, okay? Now, we also need to factor this top part. How am I going to factor that top part? Well, again, you need a trick. You need to first take the x squared, which has a negative in front of it, move it to the front of that +64. So you're really going to have a -x squared plus 64. So I'm going to cross that out because I already moved it over here. -x squared plus 64. Now, you do want to factor this. However, you don't want this to be a -x squared. Just like down here, I didn't want it to be a -x squared. I factored out a -1. Same deal here. I don't want it to be a -x squared. I want it to be a positive x squared. So I am going to factor out a -1 again. And if I pull out a -1, then that x squared will become positive x squared. And that positive 64 will become -64 if you pull out a negative sign. And when you look at the inside of these blue parentheses, you'll have an x squared minus 64. And that could actually be factored to x plus 8, x minus 8, right? You got to think what times what is -64, that if you combine together is the b value, the middle value, which there is no middle value, which means 0. What times what is -64, that if you combine together is 0, a +8 and a -8. Let's not forget about the -1 that I originally factored out. So I have a -1 out here. So what did I do here? I rewrote this, I changed the order, I factored out a -1, and then I factored x squared minus 64 with the -1 on the outside. This is the completely factored form. To make this look a little nicer, I think I'm going to rewrite what I have so far. So up on top, I have a -1 times x plus 8 times x minus 8. And on the bottom, I have the -1 times x plus 4 times x minus 8. And what could cancel out? Well, the x minus 8, the binomial with the x minus 8, that cancels out for sure. This -1 up on top and that -1 on the bottom, that cancels out for sure. So what is my final answer? X plus 8 over x plus 4. That is it right there. And if you look for the multiple choice answer on this question, you are not going to find it, right? And there's a misleading multiple choice answer. I think it's this same exact thing, but with the negative in front. But we know that that's wrong because the negative and the negative cancels out. That becomes positive. So on this particular question, on the practice test, the correct answer would be none of these are correct because this answer is not on your multiple choice.